Um, Dear students, we are going to talk about gears today. So, what is a gear? A gear is basically um, a two-thread wheel, um, and it transmits power. So, it is used to transmit power, and it is also used to transmit or for motion transmission at a certain velocity ratio. And generally gears are used in pairs. um, so at least you would need two gears to mesh with each other so that power can be transmitted. Now, there are different types of gears, and if we list these types of gears, um, there is spur gear, there are helical gears, then we have bevel gears, uh, there is worm gear, rather we will call this worm and pinion, and pinion. Uh, there is also another type of gear which is called rack and pinion. Um, rack and pinion. ठीक है? So this is another type of gear that we would use. Now, what is a spur gear? Basically, spur gears are gears that has uh, the teeth on the gear parallel to the axis of rotation, parallel to the axis of the shaft. For example, this is the shaft, um, and then this gear is meshing with another gear. For example, this is another gear that this is meshing with on another shaft. Let's say that this is shaft A and this is shaft B. So the teeth of these spur gears are parallel to the axis of rotation of the shaft. Rather, let me draw the shaft so that we can get clear understanding. So basically, this is the axis of rotation of the shaft, and this is the shaft B, where this is the axis of rotation of the shaft. So again, the teeth are parallel to the axis of rotation of the shaft. So this is a spur gear, and it is shown in this figure. As you see that the teeth are parallel to the axis of rotation of the shaft, and that is how these two gears mesh with each other. For example, this is gear 2, right? And this meshes with another gear 3, so this might be 2 meshing with 3. Okay? So spur gears are basically gears that has the highest efficiency, and these are gears in which the teeth um, have initially, when they mesh with each other, there is line contact between the teeth. So there is line contact between the teeth, and there they can bear heavy loads, um, and they can transmit heavy loads, um, as far as spur gears are concerned. Now, these gears are used for transmission of motion between parallel shafts. So they are used between parallel shafts, um, for power transmission between parallel shafts. Now, if we come to helical gears, in helical gears, the the teeth of the gear are not at the at not parallel to the axis of rotation of the shaft. Rather, these teeth are at a certain angle to the axis of rotation of the shaft. For example, these are the teeth for a helical gear. And when two helical gears mesh with each other, now the teeth of the second gear in the pair, they would rather be in the opposite direction, and they are still at the same angle, but they are at the if one gear is left-handed, the other one should be right-handed in order for helical gears to mesh with each other. So what we mean to say here is that still these are gears that are used between parallel shafts, um, for power transmission between parallel shafts, um, and between parallel shafts. Um, they are also the teeth are at an angle, and that angle is known as psi, which is the helix angle. So if this is the axis of rotation of the shaft, and this is of the axis of rotation of the next shaft, then this angle between the tooth and the axis of rotation is known as angle psi. So if one is left-handed, then the next one should be right-handed. And again, here, if this is gear 2 that is meshing with gear 3, these both are helical gears. So what is important in this gear, in this type of gear, is that the contact between two teeth is gradual, gradual contact, and not like spur gears. The teeth do not meet at once, but over here, one tooth is meshing with another tooth, and then at the same time, some other portion of another tooth is also meshing with another tooth of the meshing gear. So the contact between the gears is or the teeth is gradual, and since many teeth are in contact with each other, therefore there is increased contact area, and therefore the load that can be the power that can be transmitted with this helical gears, that is more over here, because it has more contact area, um, more contact than spur gears. And these gears, they are not noisy as spur gears. Spur gears are noisy when you operate them, because the two gears, the two teeth that mesh with each other, there is abrupt or there is a sudden contact between the teeth of these gears, and therefore there is going to be some noise. Opposite to that, the helical gears, they are not noisy and they are quiet. And again, these are, as we mentioned over here, that they're still used for transmission of power between two parallel um, shafts. Okay. Now, uh, then we have another type of gear which is called the bevel gears. Bevel gears are generally used for power transmission between shafts that are intersecting each other, or the axis of the shafts are intersecting with each other. So bevel gears would be used if we have one shaft, for example. This is one shaft. What we would do is we would put a bevel gear over here uh, that has teeth, and then put another bevel gear over here to use it for transmission of power between these two gears. For example, this is one shaft and this is another shaft. So they are both intersecting each other over here. And with the help of these bevel gears, we can transmit power. For example, this is our gear number 1. And this is our gear number 2, or gear number 2 and gear number 3, rather, I would say. Gear number 2 and gear number 3. So these it is not necessary that the angle between these two gears, as shown in this figure, this is 90 degrees. It is not necessary that this is 90 degree. It can be any angle. So and these gears, which are at 90 degree, generally they are also called meter gears. And if you have observed this, these are used in differential of an automobile. The helical gears are generally, as an example, we can say that these are used in gearboxes. And you would have seen spur gears very commonly in day-to-day utensils, in toys, in machines like wood cutting and mechanical systems like that. Then these bevel gears, they can be straight bevel gears. Um, Straight bevel gears like the spur gears, or if their teeth are straight, like for example these are now straight bevel gears, the ones that are shown over here, but they can also be curved teeth, like the teeth would be somewhat like this. Okay. So it is not necessary, but you can see both these bevel gears in systems. This one will have more contact area for the gears, and therefore will transmit more power. Now, um, there is one more thing, that in spur gears, the force that one gear would apply on the other gear, since it is straight, so that force has just one component that is applied over here. But since here, when the force that one gear apply on the other one, these helical gears generate, or um, they induce an axial load, or an axial force, which is also known as thrust. So there is a thrust load when you use helical gears. And for that purpose, there is another gear. In order to get rid of this problem, you can use a double helical gear. For example, over here, I can put another helical gear that has, let's see, we can put another helical gear where the teeth of that helical gear are opposite to this one. So I can put another helical gear in a manner on this shaft, and then over here on this shaft, where the teeth are in opposite direction. So if there is a thrust that is generated by this gear in this direction, another thrust will be generated by this gear in this direction, and it will cancel the effect of each other. It will cancel the effect of the thrust of each other. So if you have to use helical gears on shafts, you should use helical gears with opposite with opposite angles, opposite angles for, though the angle will be the same, but it will be opposite in direction so that it can cancel the effect of the thrust, and you don't have to use the bearings, thrust bearings, or get rid of the thrust load on the shaft. Now, this gear, if it is manufactured in one piece, it is also known as a double helical gear or a herringbone. So if this is a gear that has teeth like this, we will call this a herringbone or a double helical gear. Now, again, now coming to the next type of gear, which is a worm and pinion. So this is the pinion or worm gear. You can also call it a pinion or a worm gear. Worm gear. So this is the worm gear, and this one is the worm in this arrangement. Now, what is a worm and pinion? It is a gear system that is used for transmission of power between two shafts that are neither parallel, so that are not parallel, and that are not intersecting. So these are neither intersecting, non-parallel, and in that case, for example, if you look over here, this is a shaft in one plane, and this is shaft in another plane, but we have a thread-like, thread-like teeth on this worm, which is known as the worm. And if you rotate this worm, what is going to happen is that this gear is going to rotate too with this worm, because this one has teeth over here that meshes with the worm, and then if you rotate the worm, the gear will rotate, and therefore it is transmitting power between two shafts that are neither parallel nor intersecting. It is worth mentioning over here that if you move this worm, the gear is going to rotate. If you rotate the worm, the gear is going to rotate, but generally if you rotate the worm gear, the worm will not rotate, and there will be a locking over here. So generally with this type of gear system, it is only one way. And again, there is a lot of velocity, a very high velocity ratio in these types of gear systems. You can go in hundreds of velocity ratio for these types of gears. There is also another gear which is called the rack and pinion. So what does the rack and pinion do is that a rack has teeth, right? And these teeth then mesh with a gear like this. So this is called the pinion, and this one is the rack. Now, if you rotate this gear, what is going to happen to the rack? That the rack will move will do some translation. So moving this in both directions will do translation. So basically, this type of gears are used um, to uh, to these types of gears are used to change rotational motion to translation. So these are the different types of gears on either on the basis of the orientation of shafts or the transmission of motion and power that we would transmit into different between different orientations of shafts.